Alright, so for this last page of notes in Chapter 6, we are going to solve for a specified variable when you have a rational equation that has several variables. And then we'll look at a couple applications involving what we call work problems. I'll say work problems. So you're given some equations here. Let's just take them one at a time. We're asked to solve this equation for f. Students seem to struggle a lot to solve for a variable when it's in a denominator. My wife teaches high school chemistry, and she'll tell you that this is one of the biggest struggles she has with her students. But there's a simple trick we can do to make the equation so that it's more friendly. So what we can do at first is multiply every term in this equation by the common denominator, and that will make all the fractions go away. And then we'll have an equation that's much easier to solve. So if we look at this equation, we actually have three denominators. Let's multiply the whole equation by all three denominators. They're all three different. We don't have common factors because they're just variables. But this is d sub 0, d sub 1. Those aren't powers, or they're just subscripts to represent that these are really two different variables. So let's multiply everything by f, d sub 0, and d sub 1. I'm going to rewrite this equation 1 over, I'll make a cursive f, 1 over f, okay, equals 1 over d sub 0 plus 1 over d sub 1. All right, so I'm going to multiply every term by all three denominators. So I'll multiply this by f d sub 0, d sub 1. Multiply this by f d sub 0, d sub 1. Multiply this by f d sub 0, d sub 1. And let's see what happens. Okay, here the d sub 0's cancel, right? And so you get f d sub 1. Here the f's cancel, and you get d sub 0, d sub 1. And here the d sub 1's cancel, and you get f d sub 0. Okay, so we have an equation with no fractions at least, right? We're asked to solve for f. F is on the right side. There are two f's though, and people sometimes say, well, that's a problem. But we can make those two f's become one f by factoring out the f. Okay? So on the right side, I'll factor out the f. We get d sub 1 plus d sub 0. On the left, we just leave that alone. So we want to get f by itself. Now we just divide both sides by d sub 1 plus d sub 0. Okay? So that goes away, and now we have f by itself. Success, right? And so I'm going to rewrite this just to present my answer nicely. My f is equal to this stuff. D sub 0, d sub 1 over d sub 1 plus d sub 0. And that would be solved for f. Okay? So look at the next one. We're asked to solve for y sub 1. This might be a little easier because y sub 1 is in the numerator. But we do have a denominator that's kind of ugly. Let's get rid of the denominator by multiplying both sides. And since this is not so complicated, I'll just do it here. We're going to multiply both sides by the only denominator present, x sub 2 minus x sub 1. You may recognize this as a formula for slope, actually, which we'll deal with later in this class. So the x sub 2 minus x sub 1 cancel out here, right? So let's rewrite the equation. Then I have x2 minus x1 times m equals y2 minus y1. We want to get y1 minus by itself, so I'm going to subtract the y2 from both sides. So let's see, I'll write that up here. What's that look like? Well, now I have x sub 2 minus x sub 1 times m minus y sub 2 equals negative y sub 1. Don't forget there's a minus sign in front of that y sub 1. So the only thing I have to do now is get rid of that minus sign, and I can accomplish that by dividing both sides by negative 1. Or multiplying both sides by negative 1, either one. So anyway, let's see what this is. This becomes y sub 1 Now this would be a fine answer, but you might want to, I don't know, incorporate the -1 into both of these. We have two terms really, this term and this term. Dividing them both by -1 makes this first one negative, so we'd have a negative x sub 2 minus x sub 1 times m, and negative y sub 2 divided by -1 is plus y sub 2. So we get that, and if you wanted to, you could even reorder this so it looks a little prettier. I might actually write this as y sub 1, so what I'm solving for is first, is equal to, and so I can write this as a minus sign instead of a negative. I might write the y sub 2 first, so that equals y sub 2 minus, and I could change the order, that maybe I'll put the m first. M times x sub 2 minus x sub 1. So this would be a good answer. Of course, this is a fine answer here too. And in fact, even this would be an okay answer. My lab would probably take any one of those. But this is probably the cleanest, prettiest way to write it. All right, we got another one here. We're asked to solve for q in this weird equation here. Again, we're going to clear the fractions by multiplying both sides by the denominator. There's only really one denominator here. We have a product of two things. I'm going to multiply both sides by b times q plus 1. B times q plus 1. All right, so those go away here. On the left side, maybe I'll write the a, maybe I'll move the a in front. So I have a times b times q plus 1 equals 2pf, right? 2p, I'm going to write a cursive f here. All right, we want to solve for q, we want to get q by itself. So let's start moving all the other stuff. A times b times this stuff, well, we can divide both sides by ab. So we divide both sides by ab. That makes those go away here. So at this point, we have q plus 1 equals 2pf over ab. And then we're going to subtract the 1, right? So q equals 2pf over ab minus 1. And that's all. We've solved for q. One point of emphasis I'll make here. When you enter answers from these problems in MyLab is it's case sensitive. So if there's a capital letter, make sure you use a capital letter. If there's a lowercase letter, make sure you use a lowercase letter. If I would enter this answer into MyLab and use a lowercase a, it would count it wrong. If I use a capital B, it would count it wrong. So make sure you use the correct case when you're entering your answers in MyLab. All right, the last thing we have to do is look at these work problems, and there are a couple. I'm only going to give you the simpler ones. These aren't too bad. So the trick to doing these problems, you're told, well, let's just read the problem. Kelly can clean a house in 6 hours. Takes Linda 4 hours. How long would it take them to clean the house if they worked together? Well, it should take them less than 4 hours. We know that, right? Because Linda by herself can do it in 4 hours, so if she has some help from Kelly, it's going to take her a little less time. The trick is to think about the fraction of the hour each person can do the job, or the fraction of the job each person can do in 1 hour. So if it takes Kelly 6 hours to clean the house, she could do 1/6 of the job in 1 hour. So I'm going to look at what happens in 1 hour. So in 1 hour, Kelly can do 1/6 of the job, and Linda can do 1/4 of the job, right? And together they can do 1 over x of the job. We don't know what that x is, right? We don't know what that is. But if we can solve for x in this equation, we really put these two together, so we're going to add these together. 1/6 of the job plus 1/4 of the job equals 1 over x of the job. If we can solve for x, we're in business. Now, all we have to do to solve this is what I would do is clear the fractions. Now, you could add these two fractions together. In fact, a calculator can do that for you. But I'm going to clear the fractions by multiplying by a common denominator. So what do 6, 4, and x all go into? Well, we need an x, right? 6 and 4 both go into 12. So let's multiply both sides by 12x. basically we're going to multiply every term, right? Let's multiply every term by 12x. By 12x. All right? So we're multiplying everything by 12x. It should clear all the fractions. Here the x's cancel, and we just get 12, right? Here 6 goes into 12 twice, and 4 goes into 12 3 times. So let's put this all together, and we get a 2x, and we have 3x here, right? And that equals 12. 2x plus 3x equals 12. So 2x and 3x, that's 5x, right? So 5x equals 12. We divide by 5. X is 12/5. So it takes them 12/5 of an hour to do the job. What is 12/5? I don't even know. Let's see. We take 12 divided by 5. 2.4, right? 12 divided by 5 and show that. Let's see. 2.4 hours, okay? So this is 2.4 hours. So it takes them 2.4 hours to do the job, right? And that would be our answer. Let's look at the next one. This one's a little harder, but maybe not. We don't know how long it takes each of them, but we know that Michael can type twice as fast as Sharon. And together they can do they can type a certain job in 2 hours. So they're typists, I guess. How long would it take Michael to type the entire job by himself? So Michael is our X in this case, right? Again, we're going to look at what happens in 1 hour. Let's let Michael be, well, maybe we'll make it M. Why not? So Michael can do, let's say, 1/m of the job in 1 hour. We don't know his, but he types twice as fast as Sharon, so it's going to take her 2m hours to do the job, right? It takes Michael m hours, takes Sharon 2 times that, so 2m hours. So in 1 hour, she can do 1/2m. Together, we would add them together, right? We do know that together, though, they can do the job in 2 hours, which means they can do 1/2 of the job in 1 hour. Okay? If we can solve this equation, for m, we have found Michael's time, right? So we can multiply, well, what is your common denominator here? What do m, 2m, and 2 all go into? Well, 2 will go into 2m, m will go into 2m, so let's just multiply everything by 2m. The m's cancel here, 2m's cancel there, the 2's cancel here. Let's see what we have left, right? So here we just have a 2. Here we have just a 1, right? And here we have just an m. Ah, that comes out real nice. So 2 plus 1 equals m, 3 equals m. That means Michael can do the job in 3 hours. Okay? Michael can do the job by himself in 3 hours. So if you wanted to know about Sharon, it takes her twice as long. It would take her 6 hours. And together, it would only take them 2. So you'll see a couple of problems like that on your Week 2 assignment, Chapter 6 assignment. And that's all the videos for this week. So if you made it this far, congratulations. Keep working hard and stay strong.